Well, good afternoon or good morning, wherever you happen to be, friends. Welcome to another Takeo Tuesday. It's just another Takeo Tuesday. Not quite a manic Monday, but close enough. Good afternoon, good morning, etc. My name's John Barba with Takeo Comfort Solutions, and I'm joined here with two of the very best trainers in our business, Dave Holdorf and Rick Mayo. We are 3/5. You're looking at 60% of the Takeo training team. If you are regular on Takeo Tuesdays, you've seen the other 40%, Rich Medeiros and Brett Zerba, who handle
Yes.
primarily the commercial focused training. We handle residentially focused. And today we've got a great program for you. It'll be Rick Mayo presenting ECM Essentials. Everything you needed to know, ever wanted to know, or ever needed to know about ECM circulators. ECM, of course, stands for electronically commutated motor. And Rick is going to get into all the aspects of all of the different types of circulators, everything from two gallons a minute up to 200 gallons a minute, or wherever your range may take you. Show you some piping arrangements and some really slick applications.
Yeah.
A couple things as before we get started. I want to make sure everybody knows how to handle how to use the functionality here. If you're looking at your screen, you should see a control panel. If that little orange arrow at the top is pointing to the left, click on it, and that'll expand your control panel. The most important thing I want you to pay attention to there is the little section at the bottom where it says chat questions. This is how you're going to ask questions, folks. So if you could go to that for me right now and just type in a quick hi, hello, how are you? That way we know you can hear us, and that way I know that you can ask questions. And a bunch of them are popping up here. Excellent, terrific, good job, folks. Um, and any questions you have during the program, please type them in as you think of them. One of the things we like to do is we'll take questions as they come in. We'll take a break every few slides and address a couple of questions as they come in. We find that much better than waiting till the very end. That's kind of like us saying we don't want to hear from you till the end of the program. No. These things work best when they're interactive. The other piece of advice I'd like to give you is treat this as you would treat a regular in-person training class, like if we were in a classroom. So make sure you have one of these and one of these. And I want you to write stuff down. Take notes as if you were in a real presentation, a real classroom. And that's going to be the best way for you to focus. All right, if you take notes, just jot things down as Rick is presenting. That will help you maintain your focus and maintain your engagement. And it's a very, very important thing. And don't worry about missing anything either. By this time tomorrow, you will be receiving an email from GoToMeeting that will include a link to the recording. So you'll get a certificate of attendance as well as a link to watch the recording. You can watch that recording as many times as you wish. So with that said, I'm gonna hush myself right up and turn it over to my good friend and longtime colleague, going back almost 20 years now, maybe, Rick. Rick
Yeah.
Mayo, take it away. Knock
Thank
'em
you very
dead, brother.
much, John, Dave. Appreciate it. Let's jump in. What are we going to try to get done today? Well, we're going to talk about, up to the 5 modes that an ECM circulator would have. And we're going to cover those in depth, making sure that you feel comfortable with that understanding of which mode to use and when. Okay. A lot of times, the way that the system is piped will give you a really good indication of which mode of operation to be using. And so that's why we'll show you a bunch of pictures. Okay. We're going to demystify that proportional pressure mode. A lot of people say, I don't even know what that is, don't understand what the actual word even means, and how it relates with, and hopefully we'll have some things that'll help you better understand when to use that as well, because we'll give you a little sizing example. In a light commercial application that makes sense for proportional pressure, and understanding some of the things that go into that calculation as well. Okay, going to dispel the myth of these adaptable auto modes. Almost everybody has them, and they are misused. So we'll get into that as well. Make sure you understand when to use it. It's a great mode when it's appropriate. We'll get into that as well. So, and we're going to probably wrap things up depending on how time goes with an overview to our new 0026E. So let's start out by looking at things from the standpoint of the input that an ECM needs to make a decision. Okay, these They don't just make decisions on their own. There's got to be some kind of input that tells them when to do something. If they're in any of the automatic modes, they need an input to make a decision. So, okay, we've got the good old Taco Delta T pumps that have been around for a long time. Okay, that you understand that the input to one of those is 2 sensors in the Delta T mode, or if it's in a fixed speed, a fixed temperature mode, it might just be 1 sensor that it's looking at. But understand the input in those conditions are thermistor readings, 10K thermistor readings that give the circulator the input it needs to make a decision. On the other hand, we've got delta P, or pressure differential circulators, and the input to those are hydraulic changes within the system, i.e., zone valves open and closing within the system, things happening to that extent, right? So it's going to feel those things and make some decisions. So anyway, we'll give you enough information so that you can make a good decision on when to use which one, right? For the most part, we're going to focus on the delta P, or the pressure differential circulators. Again, those things needed input. So let's talk about this generally speaking. This applies to most ECMs on the market and has for years now, okay? The first thing I mentioned shortly, that these things need some kind of change hydraulically within the system in order to make a decision. So again, zone valves open and close, diverting valves doing things. Okay, you understand if the pump's running and things open and close, that changes what the actual motor can feel. We got an impeller that's in the water, it's on a shaft, that shaft's connected to the motor, that motor feels these hydraulic changes, and that's what it needs to make a decision, hence the name delta P, the pressure within that. Some people think these things have pressure sensors in them, and some do, and those can be problematic as well. So understand the motor, generally speaking, is what feels the change. We call it a pressure differential circulator. The other thing that a delta P circulator, or ECMs generally, will stay on these things that I like to call an operating range, okay? That would be this little bold line that's dotted right here that I'm showing you here or here, okay? Some people in the commercial world call it control curve. So just so you know what I'm relating to, that the circulator performance curve is this thing over here, okay? These aren't necessarily curves, they're operating ranges, okay? The other thing to realize is there's 3 major control modes, and then we kind of mix those up a bit, or we'll add some little things to one of these 3. The first one I'll bring up is constant pressure. That's an automatic mode where the circulator is staying on whatever you want it to be, and you make that selection and circulator stays with that. Proportional pressure is another automatic mode where it will move on a pitch up and down depending on what you want and how you set up the circulator. And again, we're going to dive into all these with piping schemes so you understand, when to use them. But lastly, and probably the one that people forget about the most, is even though it's a fancy ECM that does all kinds of automatic cool stuff, there's plenty of times, plenty of applications where fixed speed is the speed you want to use. So, and again, this covers the 3 kind of baseline modes of operation, and then there's a couple more that we'll add to those as well. So here's 5, for instance. We've got constant pressure, we've got constant speed. I like to call this fixed speed instead of, you say constant twice and they're going to get it confused, right? So fixed speed, proportional pressure. 0 to 10 is a mode of operation where we let somebody else control, and I'll touch on that as well. And then we have the good old adaptable automatic modes as well. So when do we use those? Let's try to clear things up and make sure that it's easy to understand what mode for what application. So understand this too, that some of these modes are manually adjusted and some of these modes are automatic adjusted. Okay, so I'm going to give you little icons in the upper right hand portion of the screen that will give you an idea. This little finger with a finger on the button is the manual, and this little circle with the A and the play button is kind of an automatic thing. So again, look up here in the upper right-hand corner as I start going through these piping schemes, and you'll know what I'm talking about. And that reminds me that we did give you a handout that will reference the same thing. So, hopefully I've made it simple just to look up in the up hand. You can see that in this case, I'm going to be talking about a fixed speed mode with this icon here and this icon here. What I'm showing you is a standard old, well, this happens to be a good old 007, the original standard efficiency circulator that's been out for a really long time and has lots of good reviews, and people just know it by name, and hence why we still have a 007, and now we have a 007E. So look at this particular curve. You understand it. It runs on a maximum speed. It's a fixed speed pump, and it runs on this. Look at this kind of like a monorail. Okay, this just means that fixed speed application is going to stay on the speed that it's on. It's not going to run down here. Definitely not going to run out here. Again, we got the filet mignon is where you should be sizing these things toward the middle third of these, and so understand that. But now let's move into what an ECM performance curve looks like. Notice you've got maximum speed and you have minimum speed. And the beauty of this whole thing is not max and not minimum, but everything in between is now we have the ability to take advantage of that now. Some circulators do that better than others. Some have more range ability than others. And these are all things to look at and to understand. But Taco's taken good advantage of this whole idea of being able to turn the circulator all the way down and turn it all the way up in a fixed speed mode, and it can take advantage of it a lot of time in the automatic modes as well. So let's focus in on the fixed speed function again. Look up here and here, and this is going to be showing you the indivisible system curve. That's your system resistance curve, particular to the piping arrangement that you put the circulator on. So if we were running at maximum speed, we'd have an operating point that would fall right there. In a fixed speed mode, when we manually change the speed of this circulator, I want you to visualize what's happening. If I turn it down, it just follows this system curve to a new location. If I turn it down again, it does the same thing. So I think you get the point of what happens in a fixed speed mode when you have a circulator running in a system that doesn't have varying flows, no zone valves and that sort of thing. So, and I'll make that point a little clearer as we get into some of the piping schemes. Okay, for instance, you realize that a zone circulator, when we're zone pumping something, right? There's nothing downstream of that that's going to change, right? Automatically, there's no zone valves or diverting valves typically or anything like that. So that circulator is a delta P, as in pressure, circulator. So its input is never going to get a signal to speed up or slow down. So understand there's been a bunch of automatic modes that have been used in this application that's not doing a darn thing, right? Again, if the circulator doesn't get the input to make a decision to make a change, it's never going to change. It just goes to a factory preset RPM when it starts up, and it'll just sit there and work accordingly. So there's plenty of pumps out there installed right now where people think they're automatically doing things and they're not. Okay, so anyway, these are one of the things to understand. Again, most of these circulator manufacturers, including Taco, you get something that has an adaptable auto mode. There's a good chance when you pull that pump out of the box, that's the mode it's in. So you got to understand when to change these modes and pull them out of the auto modes and put them in something more appropriate based on the application, in this case, fixed speed. Hopefully that makes sense. You'll see my little check mark that I'll throw in there just to say A-OK based on this mode of operation, okay? As we move or change the actual slide to show you a different piping arrangement, I want you to kind of start getting into the groove here. Look up here and say, hey, I'm in a fixed speed mode, but I see a system pump here that's going to have varying changes, within its hydraulic characteristic, right? So right here, I'm going to tell you right off the bat, I'm going to put an X there, not a check mark, right? I'll get to what mode to use here in just a minute, but I wanted to point at this one here. You can see that this circulator's responsibility is nothing more than pulling energy out of the heat exchanger, pumping it into another heat exchanger to heat the water up, right? Come back across and back in. There's its circuitry. Now, there's nothing in that circuitry that's ever going to give this circulator a heads up to change its speed. So again, understand fixed speed would be the appropriate setting for that particular unit. Okay. Let's keep on with fixed speed. You'll see there's a whole bunch of of applications that still make sense for fixed speed. As you can see, I got zone bumping here. But what about this circulator? I'll call it the boiler primary. Some people like to drop the name primary. I'm good with it as long as we're all on the same page, right? But this circulator's responsibility is nothing more than to have energy come out of the heat exchanger and drop into a T. It's going to pull whatever it needs back here and push it back, and that's its circuitry. Notice there's no automatic valves going to open and close. There's no input to that circulator to tell it to change its speed. So if you're doing something like this, save one example that I'm going to show you next, then the right mode of operation on a primary boiler circulator is fixed speed. Now, some of the manufacturers out there will give you a control signal to specifically control that circulator, to change its speed based on something inside the boiler's control. A lot of people use good old temperature differential. Some have used fan speed. Some people have done maybe something different or a blend of those two things. So if you have something like that, like 0 to 10 volt DC, that's automatically controlled by another control, by all means use it. Okay, so again, fixed speed first if you don't have either of those two things I mentioned, or go ahead and use what the boiler manufacturer would have available to control the speed of the pump. That way we can slow the pump down when the boiler turns its firing rate down and vice versa. So, John, any questions so far that we could cover?
We have not had any come up yet. So
Okay,
guys, folks out there, ladies and gentlemen, if you have your questions as Rick is going through, please feel free to type them in and we will address them as we go along. So
thank you.
nothing as of yet, but keep her coming.
All right, on. Okay, so again, I'll just go through. We got 3 pumps on the screen right now. So let's think about what mode, based on what you learned already, would be appropriate for these. And for the sake of time, I'm going to go through it pretty quick. We know this is not right, and I will cover that for sure. Okay, because look, it's got varying flows capability. That pump's going to see on the secondary portion of the system. So fixed speed is not typically appropriate for that system circulator, but by all means for the boiler circulator as well as the DHW or any heat exchanger, right, that we're feeding like snow and ice melting and things like that. There's some times where you might vary the speed on those, but generally speaking, you're going to do fixed speed on those heat exchanger applications as well. Let's go for our first automatic mode. Notice the symbol here for that, as well as the icon for constant pressure. Now let's start with an operating point, okay, just like we always would. Now I want you to say, imagine in your mind that the circulator is running at maximum speed based on all the zones being open, okay. It's not necessarily always where it's going to run, but it's just for teaching purposes. I'm going to start right here, and I'm going to kind of use a general same thing for all of them, so we kind of get used to kind of standardizing things. So if I started here and I started to close zone valves, remember the circulator has the ability to feel the hydraulic changes within the system of a zone valve closing. So what it's going to do, if I've chosen constant pressure, that's an automatic mode, it's going to change its position because it's going to feel that hydraulic change. Now notice what it's going to do. It's going to do this little hop up and then it comes back down. The hop up is nothing more than what a standard single fixed speed application does. If you know, remember sitting through pump class 101, you understand as resistance increases, it goes from the right and up to the left. So that little hop is that initial feel of the zone valve closing. Then it says, hey, but I have the ability to slow back down and maintain a constant pressure, hence the name. And so watch again as we change things. I want you to understand what that operating point is doing and why. It feels the change, it moves, but it stays on this line that says, you told me by the setting you gave me that I'm going to stay on, in this example, 10 feet of head differential. So understand that is good. And so it works good, but let's nail down when constant pressure is the most appropriate. And it's on something that's been kind of coined in the industry as a home run. Okay. A home run just means I've got supplies, there's 3 supplies with zone valves, and I've got 3 corresponding returns coming back. And this all this piping I'm showing you is what's referred to as near boiler piping. So if I'm standing in a boiler room and I have a certain number of supplies and a certain number of returns all coming back right near the boiler, you can consider that somewhat of a home run or a paralleled supplies and returns out and back, however you want to call it, just so you understand what I'm talking about. We're not going to take the time today to go through the calculation that tells us the following, but if you ever have, you'll understand that one of these zones will set the precedent for the amount of head or resistance this system circulator has to overcome at any time, right? So if one zone happens to be the one that has the greatest amount of pressure drop through it under a design load condition, then by all means, this circulator should be set up to overcome that resistance if that zone calls all by itself. Hopefully everybody's following me there. Again, we're not going to go in and do that whole calculation on this. Generally speaking, a lot of North America, Canada, and the US pipes like this. This is kind of a North American thing, and that's why TACO has said for the most part that constant pressure seems to make sense for this kind of piping. And often this type of piping will involve zone valves. So sometimes we even get it to the point to just say zone valve setting. And I'll show you when and where to have a better understanding on that as well. But it works for the most part. Okay. So again, this circulator gets the check mark. This circulator gets the red X, okay, because we've already talked about that one. So anytime you have a home run application like I'm showing you here, or maybe even something like this is people are doing these home runs. Let's say this is a thermostatic, excuse me, a panel radiator without a thermostatic radiator valve. Notice the zoning on this is right back here. Siegenthaler's shown this quite a bit in a lot of his writings and stuff. So I put it on there just because a lot of people understand what we mean by home run applications there. So notice the zoning is taken care of with the actuators down here on the manifold, but each of these panel radiators have a supply and a return that come all the way back home, right? And all this piping is right there in a mechanical room. So this would again be called a home run application. So again, check valve for constant pressure on that, because we know that one of these panel radiators, when we did the calculation and the pressure drop through the piping and the manifolds and everything, would set the benchmark that needs to be overcome by this circulator on a design day if it were to call all by itself. Okay, so hopefully I'm driving that home for a reason. Again, this circulator would be in a fixed speed or a 0 to 10 if it was available.
Rick, I have a question for you.
Okay.
What mechanism is the ECM pump using to read the pressure in order to turn up or down? Asked Kevin Walbridge.
Well, it's looking at the data that the motor is feeling, right? So the motor, the onboard computer in the little drive that's on the ECM is looking at things like RPM. It's looking at amp draw. It's looking at wattage consumption, and out of that information, it sees a change based on hydraulic changes within the system, and it makes a decision whether to speed up or slow down based on the setting that you've put the pump in.
And
Hopefully
maybe
that
the
answers that question.
yeah, maybe the best way to think of it is if all the zones are open and the impeller is spinning and we're maintaining our 10 foot of head constant pressure or whatever it is,
Yeah.
and a zone closes, all of a sudden that impeller is spinning against more resistance, which will change the amp draw, etc. So as it's spinning against more resistance and it changes the amp draw, that's a signal for the circulator to slow down.
Yeah, that's
And then if a zone opens up, it does exactly the opposite.
yeah, yeah, good. Hopefully that answers the question.
And it did, yes. Kevin's all good with that.
Oh, very good. Proportional pressure. So this is kind of the mystery mode. A lot of people don't understand what it is and what it even means. So hopefully I'll help with that as well. So again, starting at the same point, let's say all the zone valves or thermostatic radiator valves or whatever's in the system that would create those hydraulic changes within the system are open, and we've got a design day and everything's wide open. And as things start to change here, notice this thing does the same little hop. You know, it says, whoa, and it comes back up, but now it drops down. And again, like constant pressure, it's moving from the right to the left. Notice what it's doing though. It's moving a little bit different than constant pressure, right? It's moving from the right, it's moving to the left, but notice how it's kind of dropping down. And folks, it's dropping down on a particular pitch. Okay, it's pitching at, in this case, as it slows down, it's pitching downward or toward 0 GPM. Now, this is where proportional statement comes from, because the manufacturer like Taco will set a proportional algorithm within the control to say, when you slow down, thou shalt slow down at a particular proportion or a ratio of what it was at maximum speed. Remember that. Everything's based on what that particular circulator would do at maximum speed. As we slow it down, we move down in a particular pitch. Okay, we can actually look at somebody like Taco or a brand X, Y, or Z, look at their curves, and you can make a determination what that percentage was that was written into the algorithm of that particular pump. Notice that the low setting at 0 GPM, we take that and we divide it by where it meets maximum speed of that circulator. We would do it here and here, here and here, and we would come up with a number. Guess what? If I start doing that math and all of those results are really close to the same, in this particular case, it's 58%. So it drops from here down to here in a ratio of 58%. So you can always know what the proportion is just by looking at the performance curve data or the documentation from the manufacturer. It's pretty helpful in understanding, you know, what it is. More importantly, though, let's understand, when do we use proportional pressure? Proportional pressure is normally associated when you have extended headers like I'm depicting here. Notice all this piping would be in the mechanical area, right? The room, I could stand in the mechanical room looking at it. If I see one big pipe leaving and one big pipe coming back through the wall, pretend these continuation points are just discussions, right? I've got a big pipe going out, I got a big pipe coming back, yet you know that particular job has multiple zones in it, right? You say all those zones have takeoffs out there within the building somewhere. This is kind of depicting, you know, zone valves and a piece of fin tube, but the terminal units could be anything, okay? So understand there's a lot of calculations that go into coming up with this, but generally speaking, if you have an extended header application, you are going to use a proportional pressure mode regardless, okay, of what the terminal unit is, okay? So let's show you a different, that the last one I showed you was a 2-pipe direct return. This one's a 2-pipe reverse return. Regardless, okay, that the ECM is not going to balance for you from zone to zone. Okay, you have the ability for an ECM to balance its overall flow, but that's been misunderstood, and they think that these things balance themselves. You still have to take into consideration the balance from zone to zone, and in this case, I'm showing it in reverse return, which tends to help quite a bit. So again, I'm in automatic mode. I'm in proportional pressure. I'm in extended header. Okay, where the header itself no longer is right at the boiler, but it's extended out into the building, and all the takeoffs are out there in La La Land somewhere. Okay, so in this case, we would look at that from the standpoint of an extended header, just like this one. Okay, this is popular. This is more of a European style. You know, we have a ModCon condensing wall hung boiler. We've got a specific boiler circulator that's feeding into a low loss header or hydraulic separator of sorts. And then the system circulator has the ability to vary its speed based on several things. In this case, we are showing TRVs, or thermostatic radiator valves. Okay, this extends out and covers a bunch more stuff. But notice you've got the mains, you've got the branches, and in this case, you even got twigs that impart resistance to this circulator. And that's got to be part of the calculation. And for the most part, these extended header systems, especially the ones that are designed like European style, will tend to have a lot of resistance in them. We're not just designing the pump for the worst case panel rad and thermostatic radiator valve. A big part of that calculation is that extended header out into the building. So grasp that, get your arms around that and understand it. And we'll do a little calculation to help you do that. Again, I'll put my check mark right here, and I'll put my red X right there to understand what we're talking about so far. John, any questions? I'll take a short
We have a
break.
couple here. What would, I'm sorry, would the extended header remain full size for the entire run, or would that pipe size step down?
It would do most of the time it would step it down for the sake of dollars, right? Again, if you're starting out at 2.5 or 3 inch, you don't want to
Yeah.
run that all the way out there. So again, most of the time from a standpoint of cost and labor savings, the whole example of cost, labor and parts and materials and drilling and hangers and insulation and all that stuff, it would reduce down appropriate to the amount of GPM that's left on that end of the header.
And another question here, and I'm not sure if this is, if we can provide a satisfactory answer, but what factors do we need to keep in mind with a two-pipe hot or chilled water system?
Well, again, from a chilled water standpoint, we're dealing with tighter delta T's. We might be dealing with something like 12 or 10 or 8. So the flows are going to be higher, but we're still moving water. And hydraulically speaking, you still have valves opening and closing. The circulator is going to look at it pretty much the same way. So there's not a lot of difference there other than the pipe sizing based on those tighter delta T's and higher flow rates.
Very good. That's where we're at. Go get them.
Well, with that in mind, here's an example of a project that's a light commercial application. I'm just using the same drawing, so I didn't have to. I'm lazy. I didn't want to redraw it again, but I think it'll work for you. But what we're going to come up with is I'm going to put some numbers. Remember, I said there's calculations that are involved in this stuff. So, but I'm also going to say, hey, if it's midnight and it's New Year's Eve and I just need to get the heat back on, I want to make sure I can get in and out of there without doing all this. And I think for probably 98% of the time, these pictures I'm showing you, and as part of our handouts, will get you a pretty good result. So, but let's just touch on how these calculations are put together. So this terminal unit, it needed 7 at 7, this one, so on and so forth. Okay, you can see I'm going to go around the horn here, and I'm just going to, look at my calculations. What was needed based on the load, and at that GPM, what was the pressure drop through the terminal unit and everything else you'll see eventually. Okay, so at a quick glance, those who are looking at all those numbers, which one sticks out to you as being the worst case scenario as far as one of the terminal units? Those who got it are right. 9 at 12. So that's what we're going to use as a part of the design. You can't say I need, to do 9 GPM. Of course, we got to add all this up, right? So all these numbers added up is 75 gallons a minute, okay? But here's where the question lies. What should I use for my pressure drop that this circulator needs to overcome under a design condition? Well, there's a couple things that we look at, okay? Again, we know what the load is. We know the circulator will need to, under a design condition, need to pump 75 gallons a minute. But how do we come up with that number that's based on the total pressure drop that's required that the circulator needs to overcome? What about all that extended header, right? What about the supplies and the returns coming back from all that? Regardless if it's 2-pipe direct, 2-pipe reverse, there's a bunch of pressure drop associated with that. Somebody's going to have to calculate that. And generally speaking, it has a number, and depending on how that person has designed their system, a lot of times the pressure drop through that header is significant, okay? We also have to consider the near boiler piping. This would be what's near the boiler. In this case, it's shown in a primary secondary configuration, but we still have to account for incidentals. Here's a magnetic dirt separator, some T's. We got air separator, valves, flanges, all that stuff. So that has to be considered. Anybody that's sizing this right is going to make sure those are sized appropriate, nice big headers, not imparting a lot of pressure drop there. So generally speaking, this number's relatively low, but the supply and return headers can be substantial. I'm just going to throw some numbers at it. Nice round seminar land numbers that work well for a presentation anyway. Okay. Anything could change based on your particular applications, okay? So what we're trying to do is answer this question right here. What we do is we take the 18 and the 2, that's 20, we add it to the 12. What should be this number here? 32. I need 75 at 32, and that calculation based on the pressure drop of all the extended piping will, of course, include the equivalencies for your valves and fitting factor as well. We're not using a factor. For more accuracy, we want to kind of estimate. If we have no idea, then we got to use a factor. Generally speaking, we'll use, a 1.5, a 1.4, sometimes higher if you feel that's necessary. But you realize valve and fitting factors are nothing more than WAGs. And I'll let you guys fill in what a WAG is. So let's look at that same job, okay? 75 GPM at 32 feet of head. This is just showing you one of our VR 30-3s. Now notice something, that this particular pitch here is 50% pitch on this particular circulator. It is. So what I've done here is I want to show you how to slide this 50% pitch up and down in order to find an appropriate operating spot. Okay, we know what we want it to be, 75 at 32. But excuse me, when you set the circulator up, when you're pushing buttons on the interface of the circulator, you're not going to choose 32 feet ahead. What I'm showing you here is you're actually going to slide this up and down until you're right over the operating point, and wherever this pitch meets maximum speed is what you would choose. In this case, it would be 36. Doesn't mean it's going to operate out here. It just means that you have the proportional pitch in the right position. So if you got all your ducks in a row, it's going to move from here down to around here, whatever if the one zone, if called all by itself, and that's another thing that you have to make sure it's going to work for you. There was a worst case zone is up here, with everything calling, all the zones, excuse me, or a single zone. You want to make sure that this pitch will cover all of those requirements. So, how about now, John? Any questions based on that little nugget?
Nope, we got a comment from Robert Benedicts who says this is awesome. So we're doing the right stuff. Thank you, Robert.
Right on. Thanks, Robert. Okay, let's go. This is near and dear to my boss here, John Barba. So and I didn't throw it in there for that. With just a bunch of information that's out there that people have misinterpreted. I don't think any of the information was blatantly thrown out there to deceive anybody. It's just there's probably things in this seminar that I'm going to say that people misunderstand, and that's why we record it. You know, if I make a mistake, I get to watch it over and over again, right? So anyway, there's no such thing as a magic button. This is you know, it's a fallacy. You know, there's no such thing as a smart pump. We at Taco don't call them smart pumps because we know they're not smart. You are the one with the brain. Even though we put an algorithm and a computer in there, we need a human interface to make sure these things are set up right. And hence the reason we do this class called ECM Realities. Okay, ECM Essentials and the realities behind them. Okay. So let's throw out these adaptable type auto modes. I haven't covered that yet, and everybody's got one. Okay, I'm just going to throw them out there. Okay, almost everybody's got something that has an adaptable type automatic mode, and these are often misunderstood and misapplied in systems. We see it probably on a monthly basis out there, especially when they first came out, and people were saying, "Oh man, I was told all I got to do is use this mode of operation. It'll think for me. It'll do everything." And of course, we know that's not true. So again, let's make sure that we understand that auto modes are great modes, but make sure they're applied appropriately. The first thing that you have to understand, and the one that's often overlooked, is these things operate in a wedge. There's a wedge of operating condition in this little V. It's like a piece of pie, right? A V type wedge in this particular model, right? Guess what? If my operating requirement is up here, don't choose auto mode because folks, this shaded area they show you is the only place that pump's going to run. Okay, so that's where we've seen the biggest mistakes in applying an automatic mode, because it doesn't do what you think it does. Okay, and I'll get in and I'll break this down as we go when not to use them, right? Another thing to think about is, as I've already covered, you got to know that the majority of these, maybe one exception, are always proportional pressure. So the wedge of operating, that's the automatic mode of operation, is based on a proportional calculation. It's always pitched back. Okay, I'll show you, some are varying pitches, some are fixed pitches, but understand, if it's a proportional operating mode at its base, then you should apply it appropriately based on the piping of the system. And again, if it's an extended header, then that's fine. But if it's a regular home run, like we do a lot of times in North America, then that's not the appropriate way to do it. Doesn't mean it won't work. It just means that the calculation, the science behind it, is not going to work the way you think it's going to. Okay. Again, there's plenty of these pumps that have been applied in the wrong mode that are still working. And why do you think that is? That's because the damn pump's oversized, right? I mean, we don't do that in North America, do we? No. You know, and that's the only reason a lot of these are still working. But there's plenty of exceptions where they had the sizing right, where the proportional slope has actually hurt them when in a cold weather condition. People have had to go back and pull it out of these auto modes and put it in a constant pressure mode or a fixed speed. So anyway, this is what I was talking about earlier. If you look at the left side of these pitches, and they could be anybody's, I'm showing you several here, these wedges here, if they're nice and fat in the back, then they are most likely a fixed pitch, right? The pitch is actually 50%, or, you know, I showed you that one at 58, is somewhere in and around, generally speaking, they're around 50% is what most people have locked in on, okay? This is showing you, because it's back here, it's actually a fixed pitch as well. But notice how anytime you see one come back to a little point like that, then you got to understand that's a variable pitch. And in this particular one, this pitch is 70%, and then it gradually works its way down to 50%. So this portion is 50, all the way back up here to 70. So anyway, just a little nugget to understand. Just at a glance, you could look at somebody's literature, like our performance documentation, and tell whether it's a variable pitch or a fixed pitch, etc. And I show you how to figure out what the actual proportion is as well. So, any questions so far, John? I'll stop for a second.
We did have one come up from Rob Bass. If you have automatic flow control valves, to maintain specific flow through unitary devices, would constant pressure pumping be adequate as two valves close, or would you still need to consider proportional control setting? I may ask Rob to reword that a little bit. Did you understand where he was going with this?
Well, let me take a guess at it based on, I think, where he's going. The balancing is done, and if it's doing automatic balancing, hopefully it was set up under the initial design load condition. And if it's an extended header, right, and most of those commercial applications will be some sort of extended header. We normally don't have 60 supplies and returns coming back to a mechanical room, but you know, some people would like that. And but generally speaking, if it's got an extended header of any sort, the proportional mode of operation is generally the one that works best in those applications. So, other things to consider when using these auto modes, most of the time, folks, it's for use when the circulator comes on and runs for a really long time. One of the applications I showed you a picture of was, and I noted as kind of a European design with a thermostatic radiator valves and panel radiators, extended header out and all that stuff. Remember, folks, you got TRVs. Those are non-electric zone valves. There's no in switch coming back. That pump, only time it comes on is when the outdoor sensor says it should, and that's usually a 5 or an 8 degree drop above room set point temperature, and it runs until it warms up again. So the circulator is moving, right? Constant or continuous circulation, or these, relatively speaking, long run times. You know, some of the control strategies that are out there are using zone staggering and zone synchronization, and they want to run that circulator, you know, 24/7. And if the piping suits it, that might be a good time to consider some of the automatic modes of operation, like the adaptable ones that I've mentioned already. The other thing to acknowledge is these are, generally speaking, all delta P pumps. Again, if it's a delta P pump and you don't give it the signal to make a decision to speed up or to slow down, guess what? It ain't ever going to change its speed. Okay, it'll come on and off, but it's not going to do what you think it's doing. And like I've already showed you, zone pump applications, boiler circulators, right? Heat exchangers or domestic hot water indirects. I've kind of indicated that already. What's another couple? Single fan coils with pumps on them, little like zone pumps for coils. Okay, again, you take those modes that are automatic, pull them out of there, and put them in a more appropriate mode. Okay. All right. Well, with that said, and before I jump into this, any last minute questions on that?
Nope, I think we're all set. Rob
Cool.
asks, Rob says that answer you gave was perfectly adequate. So, any other questions, guys? This is now's a really terrific time to type them on in.
All right. So here's a picture of the product that's currently out from Takeo, and it's you know, it does a great job. In fact, keep your eyes and ears open. You'll probably see some new stuff out in this big dog over here on the right, and this big dog over here on the left. There's going to be some new product introduced that's going to increase this picture, this family that I've got on here. So we might put one or two out here and another bunch out here. I mean, I'll have a whole slide for this as that's coming. And most of you know about our smaller wattage ECMs. And last year we introduced the 0034E and the 0034E Plus. Great. They've done very well out in the market. People received them well, but we've got a couple other circulators that we're just starting to introduce. One of them we actually kind of already did the training on for the reps and everybody. So this is kind of like, everybody understand, we have a 0026 out there now, and 26E. Let me emphasize the ECM portion of that. And then, and this is what I'm going to focus on today. That we're going to highlight that circulator, and then we'll pretty much be done at that point in time. But we'll also just give you a real sneak peek at something that's coming in the next couple months, and that's a whole 44 watt offering, 44 watt platform offering that covers several circulators. And well, again, that's just to wet your whistle. we'll get into that when it's more appropriate, but just understand there's some really cool stuff coming from Taco on this. So we still got you covered from 3 to 300. John had mentioned the 2 to 200. I'm going, yeah, we're even better than that. 3 to 300 GPM in ECM. So little tag there. So anyway, 0026E, here they are, folks. A new product available in a painted cast iron as well as a stainless steel. And of course, the stainless steel is NSF listed and can be used in all kinds of applications, not just domestic hot water. So plenty of reasons to look at stainless steel. And now we're filling in the blanks because we've had some holes out there. And so you folks that have said, well, why don't you do this and why don't you have that? That's kind of where we're going with this whole thing. The 0026C is kind of a tweener, I'll call it, in between some things. But let's just point out what it's doing. It has 5 settings. We got a low constant pressure, medium constant pressure, and a high speed. We also got the active adapt. There's that adaptable automatic mode as well. 0 to 10 by a third party, or pulse width modulation by a third party as well. We have all that available on a simple little dial that's real easy to interpret and easy to set up on this particular circulator. Again, the market we're going after is we're to cannibalize our own 0013, right? And some 2400s, right? As well as some of our competitors. This 2699, very popular circulator, very good circulator, but it's not ECM, and neither is this one. So we're trying to say, look, folks, we have the technology. We have the ability to do a much better job with a circulator. I want you to understand what replacements we're looking at doing when we introduce these circulators. We're trying to turn this thing around. Eventually, DOE is going to force this, right? Taco's going to have it all figured out already and be ready to flip the switch just like that. Cool thing about this pump, any voltage you want up to 230, folks. So 115 to 230 with one skew. The wattage consumption goes down to 10 and only up to 120 watts, okay? The cover, you notice how I rotated that, bringing it in. Just 4 screws here. It's got a little flexible ribbon, and we can spin that thing any direction we need so it doesn't look goofy, on its side. If people want to pump left to right and not up and down, a lot of times these things will get installed and we just say, hey, you just could have flipped that. It's pretty easy. So anyway, it's got all those cool things that you folks know about already, but just making a point. The bio barrier that keeps that initial purge nice and clean. When we fill up a wet rotor assembly, we're filling it with water or fluid that has been filtered out down to 40 microns, okay? Sure start feature means if it ever did lock up, if it gets a wood chip or a pebble or anything in the impeller, it will not burn itself up. In fact, it tries really hard to break itself free, and for the most part, it does. But even if it couldn't, then it would just lock out on air and not burn itself up. You folks have been out and seen lock rotor conditions, you know that is a plus. And everything Taco's putting into these ECMs is a plus, okay? Here again, just showing you the easy to use dial from left to right here. I'll show you the actual curves here as well. So we show you 8 foot and 16 foot. These are our low and medium settings. Again, the adaptable, I'll show you that as well on a performance curve. Fixed speed is just good old contractor no callback mode, okay? And then 0 to 10, if I want a third party to take control of this circulator, it's kind of like us handing the keys over to somebody else. We do that with their blessing of knowing that, they know what to do with the pump. It's kind of out of our hands at that point in time. The whole sure start functionality will always show up. For instance, if I was running on medium, the orange, because of constant pressure mode, will show up. But if that orange light here ever turns white, you know what's happening in the background. In the background, it's trying to fix itself. Okay, it's still running and everything, and for the most part, it'll fix itself. Again, I'm just moving from left over here around in no particular a priority other than that. So active adapt, here's that wedge, but notice, within that, it's got lots of choices. Generally speaking, your automatic modes, your adaptable auto modes will float within a couple of lines here, or generally speaking, right in a fairly narrow bandwidth, because once it's been running for a while and it knows what the hydraulic characteristic of the system looks like with all the valves that have opened and all of them closed in sequence, it'll go through and it'll map out, and it knows it don't ever need to go up here and it don't ever need to go down here. So generally speaking, those are run there. But remember everything that we talked about. Generally speaking, in North America, the adaptable auto modes are the least likely to be the appropriate mode to use in North America. Here's the two 8-foot and 16-foot on your constant pressure application. So you got two settings there as well. There's the proverbial contractor no callback mode. So you can see basically this is 120 watts. Okay. So you want to run at 120 watts on a fixed speed, you've got that going for you as well. And it's the third party capability, right? So let somebody control us either with pulse width modulation, which is somewhat of a chopped signal where we look at a time length and if the unit's been powered up for a fraction of that time window, then it looks at that based on the whole time window and proportions itself back in what speed the circulator is running at, or the good old 0 to 10. And it just looks at, typically starts at around 2 volts, and you've got a linear up and down RPM selection up to 10. 10 is max speed, and around 2 or 1.5 in some cases is the low speed. So again, we're handing the keys over to somebody else at this point in time. So here's something I drew up just to kind of give an idea of what where this circulator falls. I'm showing you the one we introduced last year, the 0034E, and I'm showing you the 0026E and kind of where it falls. Okay, here's some competitors that are out there, and you'll see that both these circulators fall in very good spots. You know, somebody might say, well, this particular circulator goes way up here. But look at, if you really look at the whole picture, that's only good up to about 6 or 7 gallons a minute. Once we're at 6 or 7 gallons a minute, we exceed what that circulator can do. Same thing here. You know, this is a very popular circulator, right? It's a standard efficiency 3-speed pump that's done quite well out in our industry. But look at what the 0026E does. If I'm out around 6 or 7 gallons a minute, I exceed what that unit can do. And if I take advantage of some of those automatic modes we talked about, you know, like constant pressure or letting 0 to 10 be used, it does a great job and can just, you know, not to, you know, I shouldn't say not to mention, no, let's mention, you know, the no locked rotor condition. We call that sure start. We have the ability to see air within the system. We'll show you when somebody's not done a good job of purging and we've got air going through the volute or locked up or something. So we do some cool things. And just wanted to kind of give you an idea of what that 0026E. It's a brand new pump. We just released it, and I thought it was a good, you know, dovetail to the end of the ECM Essentials presentation. And to kind of finalize everything, now if you haven't seen a Taco circulator box that we ship it to you lately, understand that we have a cross reference on every one of those boxes nowadays, right? The new product, one of the things that we're doing is we're putting a cross reference right on there. I'll do the math for you real quick. That's 51 circulators that a 0026E will replace, including a bunch of Taco stuff, brand X, Y, Z, and W. So understand this is what we're trying to do to help people, help plumbers, help wholesalers sell a product that's far superior in just ECM itself being far superior than the standard efficiencies. And folks, depending on where we're going from a mandate standpoint, sooner rather than later is a good time to jump and update yourself. I liken this thing to looking at what a modulating condensing boiler brings to this industry. The ECM technology dovetails with that and does as good a job of that. So these are two to use. If you understand that a modulating condensing piece of equipment is instrumentally a good thing for this industry, understand that an ECM is a really good thing for this industry too. And if you're still using standard efficiency product and you're thinking about you know, upping the game a bit, want you to consider the offering, the full breadth that I showed you of TACO offering. So, John, I believe that's what I had. I leave a spot for questions, but let's call it a wrap on my end, unless there's questions that I can answer.
There's a bunch of questions here, actually. I want to get to the 0018E question in a second. Todd Dyer asked, do the pumps cycle in the summer so they don't get stuck? The circulators themselves don't cycle. Our switching relays have a pump exercise function that you can engage. So it will exercise the circulators in the summer so they don't get stuck. But Rick, you kind of touched on the shore start, which is kind of an important element in that we do everything we can to prevent the circulator from getting stuck. So could you just go over the shore start real quick for Todd?
Understand that what we're doing, because of all the electronics that we talked about that's already in the pump itself, right? This whole computer chip, so to speak, it knows what the motor is feeling. If the motor ever does get locked up, it's trying to start and it can't move and it can't move. Well, what we've done is we've taken the direction of the motor and reversed it and put it back to forward. We reverse, we forward, reverse. I'm showing you like that in slow, but guess it does that pulse of reversing and forwarding in a split second burst. Okay, it goes boom, boom, and generally speaking, it breaks itself free, especially if it's something that's just from sitting all summer long. Okay, and what it'll do is it'll break itself free if for any reason. It's going to try a bunch of times, okay? It's going to try 100 times on the little 44-watt platform. When we get up into the 120 and 170-watt platform, it tries 20 times. It's generally around 15 minutes of trial, and then all of a sudden, it'll just lock out on error. It will not burn itself up. Then that's a real, nutshell view of Sure Start.
All right, and if it in the wild, we've seen 3, maybe 4 attempts. It is really all it takes for that thing to unlock itself. We had a follow-up question. It seems like a simple add to the computer in the ECM to add the exercise function. Yes, no? Well, no, not really, because in order for it to do that, it needs power, right? If there's no call for heat, if you're connected to a relay, there's no power to the circulator. So it's not quite that simple. The thing about shore start is it really negates the need for any kind of exercising. We've had
good point.
Just very few of any of these things have ever been hit when it have been locked up to the point where someone had to come and look at them, and usually that's because something is physically stuck in there that's keeping it from going.
Or a pebble, or
wood chip, pebble, bunch of solder, stuff like that. So there's really not an issue. Stagnant water, not a problem. No, not at all. Not at all, Darren. That's a really good follow-up. With the TACO circulators, not at all, because we have also, along with shore start, we have something built in called a bio barrier. And BIO stands for black iron oxide. It's what it is. It's a brass mesh barrier that separates the water in the volute from the wet rotor. And there's no constant flow of water through there. It's just once the first water goes in, it goes in, and that's it. You might have a lot of magnetic crapola in the water itself as it passes through the volute, which is really what causes rotors to lock in other circulators. But because we have that brass barrier between the two, we've basically made the magnetics invisible to the magnetic crap in the water. So no, stagnant water is not a problem with TACO circulators, not at all, not at all. Dave wants to actually demo the shore start function. Dave, why don't you go ahead and do that?
All right, so yes, so what you see here, I took a circulator, took the casing off so you can see the impeller right here. I threw a line cord on it and a switch on the front side. So I'm going to hold this impeller in place, and the same as we get to the bigger circulators too. So I'm going to flick this circulator on, and you're going to see an LED light start to run. And then I'm holding this impeller with both hands, keeping it tight. And the light's going to stop. It flashes real quick, white, then a red flash. And now it goes back up to full speed. Regardless of the setting of the circulator, it's trying to run full speed. Stops. There's the shake. Now it goes back up to full speed, about 5,000 RPM. This is going to happen about 100 times in about 20 minutes. And I'm putting a lot of force on this to keep it in there. So this is that, if there's something stuck in there. After that 20 minutes, if it does not clear itself, the circulator is going to shut down. You'll get a solid red light on the front, and it's not going to run, meaning it's protecting itself. It's not going to continue to go burn itself out. And if you find the blockage, if you have to take it apart, just reset the power to the unit, and it goes back normal again. So that's the stuck feature. The air feature is if there's air stuck in the impeller, in the casing itself. I'm turning this one on. I'm not holding the impeller now. And now we'll get a different indication. And what happens is when you see the white flash of the light, I can feel in my hands a quick drop in speed of the impeller. So it slows down. It tries to change the pressure differential in the impeller to try to burp the air that's inside just the circulator, not purge your system. Get the air out of the circulator itself, let it get out to the system and get to the air elimination that's installed. This is going to happen indefinitely. It's going to keep on going and going and going, and unless, like this one here that I have, no water whatsoever, the motor's going to overheat. I'll get the red light. It says, all right, I need to save myself and shut down. So, two amazing features that we built into the ECM circulators to make them last a heck of a lot longer from basic items that make them fail.
We've heard many people say, well, aren't magnetic dirt separators required with ECM circulators to protect them? And our response is, well, not ours. Not ours, because we have the Sure Start and the bio barrier built in for that specific reason. Others may need them. Ours do not. Now, that said, there are a lot of good reasons to have a magnetic dirt separator installed in your system. But from our standpoint, it's to protect the boiler. Our circulators, we do not require them or even recommend them for operation with our ECM circulators because of the bio barrier, because of the Sure Start functionality. So that's again a nice. If you're looking for points of differentiation, there's one. We had another question that came up earlier, and Dave, you answered it online, but the 0018E is an ECM circulator, 44-watt platform that it's a multi-feature, multi-function circulator, in that it has a bunch of different operating modes. And it also comes with a Bluetooth radio built into it. So it connects via Bluetooth to your phone with an app on it. And the app controls the pump. Now, when you connect via Bluetooth, you have a circulator that can do a whole boatload of things. It has, I think, nine separate constant pressure settings. It has 9 separate proportional pressure settings. It has an infinitely adjustable fixed speed, meaning you got this big old blue swath of pump curve area that it could work in. So you can actually set an infinitely adjustable fixed speed. If you go by watt, it's a 44 speed pump, right? If you go by half watt, it's an 88 speed pump, and so on and so on. So how many speeds do you need here, people?
100.
100. Hey, we go by watt and a half, right? And in addition, it also has the active adapt setting that Rick had mentioned earlier, and you can pick using your phone. How do you set it up in a constant pressure mode for a zone valve system when you don't know what the actual pressure drop is? And this is one of the true beauties of the 0018E. Actually, it's just a fantastic, it's kind of, as long as you have an idea of the load and of the BTU load that you're trying to deliver with all zones calling under design conditions, as long as you have that idea of how many BTUs that is, let's say it's 70,000 BTUs. You'd have to figure it out for the job, but let's say it's 70,000 BTUs, and we're designing the system. The system has been designed to a 20-degree delta T. Well, we know using the universal hydronics formula that 70,000 divided by 20 times 500 is 7 gallons per minute. So I know my flow rate, it's 7 gallons per minute. What I would do then, open up all the zones, go into my blue mode, my constant speed mode, infinitely adjustable constant speed mode, and there's a little blue slider on your phone, little blue slider on the app, and you simply put your finger on the slider and you move the slider until you see the readout at the bottom reading 7 gallons per minute. Once you hit 7 gallons per minute, look right next to it. It's going to tell you the head loss. All right, it's going to tell you the head loss. Let's say it's 7 gallons a minute and it comes out to 8.5 feet ahead. Cool. Now you change the operating mode to the what we would call the orange mode or the constant pressure mode, and then you select the constant pressure line that's closest to 8 feet ahead. In our case, it would be 9 feet ahead. So you just press that with your finger. You simply press the curve with your finger, and bam, you have programmed a delta P pump about as well as a delta P pump can be programmed. That's very exciting and really groundbreaking. So we're real excited about that. Very good. And William McNamara says, I see the 0018 as more of a tool to see where the system, what the system sees versus a change out pump. Well, sure, you can use it any way you wish. Certainly use it any way you wish. In terms of a
man hour is expensive though, so I mean, as long as
yeah,
you're for it,
you're putting in a pump and seeing what the system's doing. Then what are you doing with the information? You're picking a different pump and putting that in. Okay, that's cool. It's your time, right? It's your time. It's a matter of if the price is something that you object to, it's your call. You know, really, it's more expensive than say a 0070 or a 0015E, but you know, once it's in, it's in. So it's 6 of one, half a dozen of the other. We've heard of many other people who have used it in that manner, William. So yeah, that's a perfectly acceptable and very cool way to use that circulator. And Darren asked, with Bluetooth circulator, how does the app function if you have multiple circulators in a system? Simple. You name them. So you pair with one circulator at a time, right? When you pair with one circulator, you say, okay, this is the first floor circulator, and then this one's the second floor circulator. Or you can give them names. You can call them Mo, Larry, and Curly, whatever you want to do, so that you know which one. So you pair them at one circulator at a time, and adjust that circulator. Back out of that one, pair it with the second circulator, and give them each unique names if you want to. Okay. Otherwise, it'll just say, you know, 0018E1, 0018E2. But yeah, it's best to give them a name, and there's a function for doing that within the app. So cool. All righty. Well, this was a lot of fun. Any last minute questions out there, folks? We do appreciate the gift of your time today. Always good to be able to spend some time with you folks on a Tuesday. We had, I think we peaked out at 240 people on the session. So awesome. Thank you for that. Thank you for being with us. And Dave and Rick, any last words for the gang?
No, same thing, man. You know, we're going to keep doing these as long as you guys keep showing up. Take-O Tuesday is going to continue. If you've got any ideas whatsoever, you have our emails, all right, on a class that you would like to see. Please give us a call. Please contact us, contact your local reps on something that you would like to see for future classes. We pretty much have about a third of this year already settled out on what classes we're going to do, but we're open to suggestions, and we can always build some things that would benefit all of us. So please send those suggestions in. Thank you.
That'd be great. I've done all the talking. So other than thank you very much for your time, you know, appreciate you coming. You know, come see us again. Take-O Tuesday.
Thank you, Rick. Awesome presentation.
Yeah, thanks.
All right. Take care, everybody. Have a great week.